Hello and welcome to my YouTube channel, Amazing People. I'm super excited to be here with you on today's episode on this series of learning how to balance chemical equations. My name is David and I'm also known as the Billionaire Teacher. All I do here is to take the mystery out of chemistry so you can make history. And on today's episode, we're learning the advanced balancing techniques and cases where we have the polyatomic ions. So let's get into what we have for today's video. So we're starting off by defining what a polyatomic ion is so you can understand and see how to balance them when they are in chemical equations. So polyatomic ions are groups of atoms that act as a single unit, more like a team of atoms. Okay, so you have 1, 2, 3 atoms coming together, acting as a single unit, and then they carry a charge. You often see them inside brackets or grouped in formulas. Now, here are some examples of polyatomic ions that we have on the screen right now. The first is the hydroxide ion. The hydroxide ion has this symbol OH. So it combines the elements oxygen and hydrogen. So you see oxygen and hydrogen coming together as a single unit called the hydroxide ion, and usually it is contained in a bracket. The next one is the phosphate ion. The phosphate ion combines two elements, phosphorus P and oxygen O. The third one is the nitrate ion. The nitrate ion combines two elements, nitrogen and oxygen. And then the fourth one being the sulfate ion, which combines sulfur and oxygen. And then finally, we have the carbonate ion, which combines carbon and oxygen. So oftentimes you see polyatomic ions contained in a pair of parentheses, also called a bracket, and they carry a charge. So whenever you have a couple of polyatomic ions in your chemical equation and you want to balance them, it is important to know first of all that they do not break apart in a reaction. Okay, so you can balance them as a unit, not atom by atom. Here is what we mean. For instance, if you have the sulfate ion SO4 on the reactant part of a chemical equation, and then you have that same sulfate ion SO4 on the product part of a chemical equation, what we're simply saying is that to balance that equation, you treat this SO4 as a single unit. So you do not begin to balance sulfur first and then oxygen next. No, you simply balance this as a single unit. So what we mean is, for example, if we have SO4 and then it has a subscript of 2 outside this bracket, and then there is an SO4 over here, what you simply do is just to add a coefficient of 2 over here to make both sides to be balanced. All right, so if the polyatomic ion appears on both sides of the equation without changing, treat it like a single item, and that's what I just showed you how to do. So now that we've seen that, let's treat a couple of examples and then we'll draw the curtains on today's video. So we have the first example on the screen right now. Okay, so first things first, the question we ought to ask ourselves at this junction is, are there any polyatomic ions that appear on both the product and on the reactant side? Yes, there is, and I've identified one. We have the phosphate ion, which appears here, and it also appears here on the product side of the chemical equation. So let's balance the polyatomic ions first, and then we can move on to other parts of the equation. So for the polyatomic ion, we have H3PO4 yielding Ca3PO4 2. So for this polyatomic ion, on the left hand side we have just one unit. On the right hand side we have 2 units because of this subscript of 2 that affects everything that is inside this bracket. So in order to balance it, we simply add a coefficient of 2 over this side of the chemical equation so that this polyatomic ion here can now become 2 units on the left hand side and 2 units on the right hand side. So therefore the equation now becomes CaOH2 plus 2H3PO4 yielding Ca3PO4 2 plus H2O. So as you can see now, we have balanced the first polyatomic ion. 2 units on the right hand side and 2 units on the left because of this coefficient of 2 that we have just added. So now that we have done that, there is another polyatomic ion, which is the hydroxide ion, which appears on the left hand side of the equation. But there is no hydroxide ion on the right hand side. So we're just going to proceed balancing all other elements in the chemical equation. So the other elements in the chemical equation that is not yet balanced, I've identified it to be carbon or calcium. I beg your pardon. Ca stands for calcium, not carbon. Carbon is denoted by capital letter C. All right, so for calcium, we have 3 atoms of calcium on the product side because of this subscript of 3 over here. But for calcium on the left hand side, we have just 1 atom of calcium. So that tells us that we need a coefficient of 3 over here to balance calcium. So the equation now becomes 3CaOH2 plus 2H3PO4 yielding Ca3PO42 plus H2O. So we have balanced the phosphate ion and we have also balanced the calcium atoms as well. So the next thing to balance now is to balance for hydrogen. So you can see on the left hand side of the equation, we have some hydrogen atoms. How many hydrogen atoms do we have? So let's begin to count. So for hydrogen, on the left hand side, we can see an atom of hydrogen over here. Okay, now this hydrogen has a subscript of 2 here, and it also has a coefficient that affects the entire molecule, 3. So we have 3 times 2, which gives us 6 atoms of hydrogen. Over here, we also have another atom of hydrogen, which has a subscript of 3 and a coefficient of 2. 3 times 2 as well also gives us 6. So altogether, we have 6 plus 6 atoms of hydrogen, which gives us 12. On the right hand side, you can see over here we have just 2 atoms of hydrogen. So in order to make 12 and 2 equal, we just simply multiply by 6. So that tells us that we need a coefficient of 6 over here. I'm sure you're following every step of this balancing technique. So now the new equation now becomes 3CaOH2 plus 2H3PO4 yielding Ca3PO42 plus 6H2O. So at this point now we have balanced hydrogen. The polyatomic ion is also balanced on both sides and calcium is also balanced. So at every stage, we'll keep checking for each element if they are balanced on both sides. So now let's count. As we have balanced thus far, let's count each element both on the reactant side and on the product side to see if they are equal. So at this point now, we want to confirm if all the elements are balanced on both sides. So let's start with calcium. On the left hand side, we have 3 atoms of calcium. On the right hand side, we also have 3 atoms of calcium. So calcium is 3 on both sides. It's balanced. Okay, so next up we have oxygen. So let's be careful while we count so we do not misplace subscripts and coefficients. So here is 1 atom of oxygen. It has a subscript of 2 and a coefficient of 3 over here. So we have 3 times 6, 3 times 2, I beg your pardon, which gives us 6 atoms of oxygen. There is also another atom of oxygen over here. Okay, it has a subscript of 4 and a coefficient of 2. That gives us 4 times 2, which is 8. So altogether, we have 6 plus 8, which gives us 14 atoms of oxygen on the left-hand side. How about on the right-hand side? Let's check it out. Okay, here is 1 oxygen atom. It has a subscript of 4 here. And then there is another subscript outside, which shows us 2. So that tells us, well, we have 4 times 2, which gives us 8 atoms of oxygen. And over here, we have another atom of oxygen, okay? It doesn't have any subscript here, but it has a coefficient of 6. So that gives us 8 plus 6, which is also 14. So oxygen is balanced as well. The next element we have is hydrogen. So on the left hand side, you can see we have an atom of hydrogen over here. It has a subscript of 2 and a coefficient of 3. 2 times 3 gives us 6. And then next up, we have another atom of hydrogen over here. It also has a subscript of 3 and a coefficient of 2. 2 times 2 as well gives 6. 6 plus 6 gives us 12 atoms of hydrogen on the left hand side. On the right hand side, you can see we have one atom of hydrogen over here, having a subscript of 2 and a coefficient of 6. That gives us 6 times 2, which is 12. So we have hydrogen, which is 12 on the left and 12 on the right. Hydrogen is also balanced. And then finally, we have phosphorus, P. So we have one atom of phosphorus over here. It has no subscripts attached to it, but then it has a coefficient of 2 over here. Okay, so we have two atoms of phosphorus on the left hand side. On the right hand side, you can see an atom of phosphorus over here, and it is enclosed in a bracket that has a subscript of 2. So that 2 affects everything that is in the bracket, including this phosphorus. So we have 2 on the left and 2 on the right. Phosphorus is balanced as well. So our final balanced equation is 3Ca OH2 plus 2H3PO4 yielding Ca3PO42 plus 6H2O. This is our final balanced equation. I'm sure you saw how every step was meticulously taken, precept after precept. All right, so now that we have dealt with that, let's move on and see if we can deal with yet another example before we cross or call it a day for today's video. So here are some practice examples for you to deal with. I'll leave this one up to you to check it out and see if you can do justice to it. So we have the next practice question over here. Let's deal with this very quickly. So first things first, let's check out if there are any polyatomic ions in this chemical equation that appears on both sides. Okay, so we have the first polyatomic ion over here, NO3. Does it appear on both sides? Yes, we have NO3 as well here. Okay, and then we have another polyatomic ion here, SO4, and it also appears on the product side. So let's deal with the polyatomic ions one after the other. For the first one, NO3, you can see it is closed in a bracket and it has a subscript of 2, which tells us that this polyatomic ion appears 2 times, or it has 2 units that appear. On the other hand, we have NO3 appearing only once. So that tells us that in order to make them equal, we need a coefficient of 2 attached over here. So this equation now becomes BaNO3 2 plus K2SO4 yielding BaSO4 plus 2KNO3. So at this point now we have balanced these polyatomic ions. This one is balanced on the right and it is also balanced on the left. So now the next thing to do is to check out other atoms if there are no more polyatomic ions. Now you can see SO4 on the left is just 1 unit. SO4 on the right is also 1 unit. So it is balanced as well. We have barium, Ba, on the left hand side, just 1 atom, and Ba on the right hand side, just 1 atom as well. It is also balanced. And then we have K, potassium. How many atoms? 2, because of this subscript of 2. And then K over here is also 2 atoms because of this coefficient of 2. So potassium is also balanced. So our final balanced equation is BaNO3 2 plus K2SO4 yielding BaSO4 plus KNO3. 2KNO3. This is our final balanced equation. All right, so Now that we've dealt with that, let's see if we can treat one more example and then we'll draw the curtains on today's video. My bad, that's all for now. So next up, we're going to be looking at the algebraic method for balancing chemical equations. Okay, I'm so glad if you stuck around till this point in this video. Thank you for engaging with the stuff that I put out here. My name's David. It's been a pleasure connecting with you. All I do here is to take the mystery out of chemistry so you can make history. I look forward to seeing you in the next episode where we learn the algebraic method of balancing chemical equations. Till then, stay safe and thank you.